Hi guys, thank you all for coming out this morning. What a great venue this is. I even might stage dive afterwards. Great to speak here. My name is Edwin, and I'm gonna talk a little bit about the recipes package. And recipes is a package that was designed by Max Kuhn, with a little bit of help from his friend Hadley Wickham. You probably know both of them. And in Max's own words, the recipes package is a set of pre-processing tools to create design matrices. And in my own words, that's basically a set of tools that allows you to go from the raw data, so the data that you start with, and prepare them in such a way that they are ready to fit into your model or your algorithm or whatever you want to do with them. So let's show some hands. Who of you have used the package already? Oh, quite some people. And people who heard about it but don't really know how it works? Yeah, that's what I figured, so great. Thank you all for coming here. So I prepared a little intro to the package because I figured that some people didn't know about the package. But this is not an introduction to the package. I'm actually gonna tell you a little bit more about how to add your own preparing steps to the package so you can fully leverage the package. And I think if time allows, there's one example on actually applying this recipe for recipes. That's what I called it. So it's actually a recipe how to create a recipes step. All right, so a recipe is itself not the preparation of food. It's actually describing how food should be prepared, and the exact same holds for the recipes package. So actually building a recipe is not preparing your data itself. It's more a declaration of an intention, so how the data should be prepared. And I'm gonna use the infinitely interesting empty cars data set to not get you distracted from the data. I'm gonna split that in train and test. So just take the first 20 rows, put them in train, and the other 12 rows, put them in test, just for matter of example, of course. And here, the recipe is actually specified. So we specified on the train set, so we're not preparing the train set, but we say, well, please take the train set, and we're going to build a recipe on that. It only has 3 columns, so I did a selection of 3 columns. And you also see the formula, and that means that we already designating the AM column as the outcome column, and with the dot we declare that all the other columns are the predictors. And here you see 2 steps added to the recipe. So here the REC object is the recipe, so that's just an empty recipe, no steps added to that yet. And here we add 2 steps to that. So the first one is centering, which is just subtracting the mean. And the second one is scaling, which is dividing by the standard deviation. And you also see that the tidy select package is used, so all predictors. So we don't have to declare all the columns on which we want to do this step. In this case, we only have 2 predicted, the disp and the HP columns. But of course, in real life examples, you probably have many predictors, and so this is very convenient. You say, just I want to prepare this, I want to perform the steps on all the predictors. Alternatively, you can also say all numerics, all categorical, stuff like that. So it's really convenient. Max has a full-length tutorial, about an hour online. So I certainly recommend you looking at that tutorial. But for now, this is all I'm going to tell about it, because otherwise I don't have any time left for what I really want to tell. So when you're happy with your recipe, you actually start prepping it. And prepping is not yet preparing the data, it's updating your recipe. And prepping is learning all the necessary statistics from the training set. So probably, as you know, if you want to prepare your data well, you learn statistics for centering and scaling on a train set. But you have to apply the same statistics on the test set. So you don't want to estimate the mean and the standard deviation on the test set. You want to use the standard deviation and the mean that were learned on the train set. So the data you're going to feed into your algorithm is prepared in the exact same way on both train and test. That's a really bright spotlight, by the way. I'm only noting it when I'm moving out of it. I actually see people are in the room. So when your recipe is prepped, so prepped means that your recipe is fully ready to be performed on the data. Then you start baking your recipe, and it's only here that you actually do preparing your data. So all the steps before, adding steps to the recipe and prepping the recipe, is just updating the recipe. You don't do anything on the data yet. And here you bake it, and baking the recipe is actually performing actions on your data. And you see you bake with the recipe, the train set, and the test set. And this ensures that the preparations are in the exact same way, the preparations are the exact same on both train and test. So recipes does all the bookkeeping for you, which is very neat, because if you ever done preparations by the hand and you have to store all the statistics in a list, it gets very messy easily. So recipes is, I think, a great package, and I can say that because I didn't write it. And finally, there's a tidy method on the recipe, and this gives you all the steps that are in your recipe in a data frame format, so you can store it nicely, and you can actually keep track of everything that's happening. And you see if the steps are trained already. So you see in this time the recipe is already prepped. So you see that the steps are trained in the third column, or fourth, that is. And now you might wonder why I'm talking about this, because it's not my package. Well, I did a little extension of this package together with Max. We added checks to this. So their steps were originally introduced, of course, that's the whole aim of the package. But checks don't do any data preparation. They make assertions of the columns present in your data frame, and as mentioned, they don't do anything. But if the assertions are not met, for instance, in the little code snippet, I add the check missing, so that actually asserts that there are no missing values in a column. And if you feed a data frame to the baking step that actually have missing values, then it will break and say, oh, wait a minute, you asserted that there are no missing values in this column, but they are. So that's why I'm pretty suitable to give this talk, because I learned how to contribute to the package the hard way. And it's so as you've probably seen from the examples, it's a really nice, smooth package, as you might expect from the tidy first team. So it's really designed to work smoothly. But if you want to contribute it, it's a little bit more complex. And I think many people could fully leverage the package the best way by adding their own steps. So we all have our own preferred ways to prepare our data. And even if you think you have something that Max didn't add to the package yet, so he has, I think, 30 or 40 steps, and we are currently expanding the checks. But if you think, well, this is something that's really neat, and I think everybody could benefit from that, you can, of course, do pull requests to the package. It's a little bit more challenging, because recipes does all the bookkeeping for you. So if you add a step, you have to implement all the bookkeeping yourself, and you can get a little bit distracted by the bookkeeping, and it's can be a little bit annoying to actually implement the stuff you want to do. So that's why I need to say one more thing before I really get going. So the recipes themselves are S3 classes. If you're not sure what S3 classes are, please stick in this room, because the next speaker is going to explain them, I saw on the schedule, so that's going to be very interesting. And so recipes are of their own class, and all the steps and checks have their own subclass. So steps and checks are of class step or check, but also of subclasses specific step or check they are. And you have to provide with methods, so the prep and the bake methods for your subclass, and once the prep and the bake methods on the recipes are called, they call on all the prep and bake methods of the individual steps and checks that are in that recipe. So that's something I want to tell you up front. So if you want to create a custom step or check, you need to provide with 6 things. So that's the actual function, so like the step center or the step scale, that's are the actual functions that add that step or check to the recipe. You need a constructor, so that's a uniform way of how to create something of a specific class. And you need to provide 4 methods, so you need to prep, the bake, the print, and the tidy methods. So you can fully work, so your step or check fully works. So this is my recipe for recipe. It comprises 8, well, I'm not going to say steps, but 8 points or I don't know, I'm not sure how to call them. So first, I think the best way to provide a new step or check is to not bother about recipes at all, but just focus on functionality, the thing you want to do in your bake. That's in the bake step eventually. And then you're going to sit down and think, well, which of these arguments should be provided up front? So in the step or check function, actually to add it to the recipe, and which should be learned by the prep method of your step. So once you have done that, you write your constructor. Next, you write the actual function that adds your step or check to the recipe, and then you're going to write the 4 methods you need. So I've prepared 2 examples. I probably have time for only one, so that's what I figured. So the others are at the back of the slide deck, and on my final slide you will find a link to my GitHub, and there you find all the slides, and also 2 skeletons that have all their overhead that you need in them, standardized in a way so you don't have to copy-paste everything from another step or check. So we're going to do a signed log. Really simple example for time matter, of course, but it's nevertheless useful. I use it a lot. So it's a log on a variable that can also be applied on negative values. Of course, the log doesn't exist on negative values. But if you take it on the absolute value of your variable and then swap it back to the original range again, so you multiply it by the sign of the original variable. So you take the log of the original of the absolute value, and then you multiply it by minus if it used to be a negative value. Everybody clear? Is that clear? Yeah, it's not too complicated, I guess. And oh yeah, if the absolute value is smaller than 1, you just put it 0 because otherwise things get messy. So if we were to write a function, if the recipes package did not exist, we would probably do it this way. So we just take the sign of x and multiply it by the log of the absolute value of x. So that's the function if recipes did not exist. And now we're going to think about what do we need to provide. Well, as I mentioned, it's a very simple thing, so it's a bit trivial for recipes, but otherwise I would be here this afternoon still, probably. And so we only have one argument, that's the base, right? So it defaults to the natural logarithm here by providing the exponential of 1. But that's something you could give as an argument to the user. And there's nothing to be derived here by prep, so basically prep is doing anything here. But that's in the case because there are no statistics to be learned at the prep stage on the train set. In the other example, which is a little bit more involved, that you can browse over maybe this night, then actually there are statistics learned in the prep stage. And this looks maybe a little bit daunting, but as I said, there is a lot of bookkeeping here. So terms, roles, skip, and trained are all default arguments of every step. So this is the constructor. So this is not called by the user, but this is called internally. So that's always in the recipes package. It has the new extension. So the step signed log will be the function to actually add this step to your recipe, and the new will is a constructor to get new objects of this step signed log. So that's step is an internal package, so you should always download the source code from Git. From Max, I'll have a link at the last slide. And we only have the base argument that we provide up front. And columns is just a way to select all the columns in the prep stage to keep track of the columns on which this step should be performed. So it's null for now. And well, this looks like doing the same thing, but it's actually, this is the function that does add this step to your recipe. And you see here, so add step is an internal function, which is of course provided by recipes if you clone the source code. And you call the constructor here, so you add the step to the recipe, and you call the constructor to add this step to the recipe that's already there, of course. And now you go on with the methods. As I mentioned, the prep method is not doing anything at all. It calls the constructor again, so it's updating the step that's in your recipe. And the only thing that's done here is term select, which is an internal function again, and that's basically transferring the thing you called for tidy select. So if you had all predictors or everything, so that's swapping that for the actual column names. So you have the actual column names ready in your baking step. So when you're baking, this is where the actual function is performed. Please remember that all the steps previously, so adding steps and doing prep, are just updating the recipe, and here the actual data preparation is happening. So we're retrieving that's columns again. So in the prep stage, we have converted the tidy select to the actual column names, and in this stage, we just get them back. So we have a vector with the column names. We loop over them, and we perform the signed log on each of them. So we're actually preparing our data. And then the two smaller functions that are a little bit more trivial but should be provided for nevertheless. So printing, so this is all in a standard manner. So you only have to update the string there that actually says what you're doing. And this is to ensure that your recipe is printed when this step is present in a nice and clean way. So you're not outputting all the lists, because steps are lists with all kinds of information in them. But you don't have to worry about that, because you call the step function or the check function internally. So you have those are constructors for check and step, and you only have to provide the detailed information that makes your step or check special. And then finally, the tidy. This adds the column to the recipe output, or to the output when the tidy method is called on the recipe. So that's the example. We put it to practice to see if it works, and here we have created our own step, so a step signed log that's not provided by the package, but we've written it ourselves, and it works fully when added to a recipe on a very trivial data frame, of course, but that's for the matter of example. So you see, I'm not done with the slide deck. So after the last two slides, there's another example with a check. So that's a range check, and you can browse through them yourself. And I also will put this presentation to a blog post. There, I'm going to wrap up here. There are slides and the skeletons. So that's actually all the overhead. You just have to copy and paste and just provide with your own personal information. Those are my GitHub. You need the source code from Max's GitHub. So Pipo, that's Max Koen, if you didn't know. It's a bit of a funny name, but I'm not sure what it means, but that's it. And if you want to know a little bit more about the recipes package and to fully use it, please go to the presentation here. That's a full hour webinar by Max, and it's really useful if you haven't seen it yet. So that's it. Here you find how to reach me. So that's my email, my Twitter handle, my little website on which I'm going to post this blog in the upcoming month, I guess, and my own GitHub. Thank you all.
Wow, just in time. Thank you, Edwin.
Yeah.
We have 2 minutes for questions, so maybe a question or two. I don't know, it depends. Any other questions?
Or none? Oh, there's one.
One. Maybe I should bring a microphone.
Thank you for your job and for your presentation. And what about outliers? How can we work with outliers with this package? So we can check for missing values, maybe for something else. And what about outliers?
Yeah, so the challenge there is to there's of course a whole bunch of theory about outliers and what should be done with them. And so alternatively, there's Max that did a lot of work on imputation. So he did the official imputation methods and provided them in a step. So it depends on what you want to do with outliers. So I'm thinking about it still, but I'm still reading actually about outliers. So the other example here, I'm already switched off, I'm afraid. So yeah, so I'm the only one seeing this now. Okay, so actually the other example is a range check. So it checks if the range of the variable in the train set is the same, or in the test set is approximately the same in the test or in the train set. I'm sorry, I'm messing that one up. So it checks if the range of a variable in the test set is approximately the same as in the train set. So that's one is when it's going to be implemented soon. So that's more the general range, but it also captures outliers. So so recipes is a way to create your own way of dealing with outliers. So if you have a preferred way, you should definitely make it into a check. Or you should open an issue and say, well, I want to do something with outliers, but I'm not sure how to do it. And you can have a discussion with me and Max and whoever is working on this. Sure.
Okay, I don't think that we have any more time. So, Edwin, thank you.